story so far. All solids consist of little lumps of matter which are continuously vibrating to and fro in a latticework pattern. It is this latticework of little lumps that keeps the solid from falling apart. The scientific word for little lump is molecule. And now, molecules in liquids. That chocolate rabbit that's sitting beside you, now that's a solid, isn't it? Because a solid is something that keeps its shape, right? And even though the molecules inside it are vibrating pretty fast, they do all keep together. Everything is orderly and under control, so the latticework pattern remains intact. And as long as you leave the rabbit alone, it will stay in the shape of a rabbit, won't it? Or will it? You forgot about the sun. The sun makes things hot, and when things get hot enough, they melt. They become liquid. They lose their shape. Liquids have no shape or form at all, except the form of whatever container you put them in. But if you leave a liquid alone, it will slop all over the place, as it's pulled down to earth by the force of gravity. In fact, it's so keen to get as close to the earth as it can that it will flatten itself out as it seeks the lowest possible level. But what happened to that nice, orderly arrangement of molecules that gave the rabbit its form? How could those well-behaved little molecules have allowed the solid chocolate rabbit to degenerate into this liquid chocolate splodge? Let's reverse the process and find out. The rabbit is sitting on the wall, all calm and collected and cool. If we could look at what's going on inside it, we'd see that its molecules are equally calm and collected, vibrating happily away in their latticework to a steady, even rhythm. Each pair of molecules being brought together by a mutual force of attraction, and then pushed apart by a mutual force of repulsion. Fine, until the heat of the sun gets to them. As the sun gets hotter, the molecules become more and more excited and go faster and faster, swinging to and fro more and more wildly. The hotter they get, the faster they go, until the inevitable happens. The force of attraction is no longer strong enough to hold them, and they burst apart as if snapping an invisible spring. Now it's a free-for-all. Molecules are barging into each other, right, left, and center, changing direction continually, slipping and sliding past each other, getting thoroughly mixed up. The speed of the heated-up molecules has caused them to slip out of their regular latticework, and everything has become a complete shambles. And so the rabbit falls apart. It loses its form and turns into a shapeless mess. In other words, it melts. That's what melting means. The breakdown of order, the collapse of the pattern of vibrating molecules that's been holding the solid together. So the solid becomes a liquid, because the molecules not only do a lot of bumping into each other, but they also do a lot of slipping and sliding past each other. And the more slipping and sliding they do, the more easily the liquid flows. So when it's hot, molecules speed up and solids turn into liquids. Just as when it gets cold, molecules slow down and liquids turn back into solids.